Okay, good evening. As promised, we're now looking at psychrometry. That is going to possibly be a bit of a refresher for those of you who already have done this course. And then, of course, there were a couple of you guys who were late enrollments. So this is going to be something new to yourself. So, yeah, it's a very interesting topic, this, and I normally start off this type of course by putting a disclaimer in and just stating that what I'm going to be teaching you is basically the tip of the iceberg, because psychrometry itself could take you a whole year and you still more than likely wouldn't understand it all. But what I'm going to be doing is I'm going to be giving you a brief overview of psychrometry, and I'm going to give you some basic type of examples that you can work through that will assist you as you go along into the real world of it. Okay, now first of all, psychrometry is a study of the properties of the mixtures of air and water vapor. The subject is basically important, or is very important in air conditioning practice, because atmospheric air is not completely dry, but it's invariably a mixture of air and water vapor. Some air conditioning processes, water has got to be removed from the air-water vapor mixture, and in others, water has got to be added. So in some cases, you've got to dehumidify, and in some cases, you've got to humidify. So we're going to be looking at a couple of these things. But first of all, it is important just to understand the psychrometric chart itself. So I just want to get the psychrometric chart. Sorry about the bump. I'm using the Sean Slade's method. He suggested that I look at recording like this, so I'm giving it a shot. I don't know how successful I am, but anyway, I'm just going to plod along. As I mentioned earlier in some of my other lectures, that I'm not a movie star by any means, so yeah, this is quite hair-raising for me. I suppose it's very hair-raising for you too. Okay, psychrometric chart. There's quite a lot of detail on this thing. First of all, you'll have a look over here. It basically says it's a psychrometric chart for a barometric pressure of 101.3 to 5 kPa. So in other words, this is for sea level. Now, whatever you do, if you suddenly decide in your madness to immigrate or to relocate up to Johannesburg, you won't be using this psychrometric chart. There are psychrometric charts for various areas, so you will look for the one that is designed around the area where you'll be staying. The next thing, on the psychrometric chart, you'll see at the bottom over here, the x-axis. It talks about a dry bulb temperature in degrees Celsius. On the y-axis on this side, there are two scales. Number one, the inner scale is a moisture content, that's in kilograms per kilograms of dry air. So in other words, when I talk about a moisture content, that is the amount of moisture you will find in 1 kilogram of dry air, for argument's sake. The next scale on this side of here, we'll use it a little bit later on, is the sensible heat factor. That is when we start plotting this diagram and we start making use of it in its entirety. The next thing you'll see over here, running at an angle, sort of at an oblique angle, is the volume. And the volume is in cubic meters per kilogram of dry air. Now be careful, for this particular course, we don't work with liters per second and those type of things. We deal with cubic meters per kilogram. So if you've got liters per second or cubic meters per second and so on like that, you're going to have to calculate that out to make sure that you're working with cubic meters per kilogram of dry air. Right, then we've got this line that proceeds up over here. Now that line is your saturation line. I'm going to talk a little bit more about that as we go along, but that is a very important line called the wet bulb, or it's called the saturation line. Okay. On the saturation line, you'll find there's -5, 0, 5, 10, 15, 20, so on. That is your wet bulb, or your saturation temperatures. That is placed on that line. Okay. The next thing you're going to find is in here, you've got these other lines that slope downwards, or slope upwards, whichever way your pen is moving. And you'll notice over there it states that is relative humidity. So in other words, at that point over there, anything on that line is the relative humidity will be 50%, and 40%, 30% further on. Okay. Then on this side over here, the final thing that we're going to be looking at are these scales over here, and those scales is your enthalpy in kilojoules per kilogram of dry air. So if you look at it in terms of this, the amount of data that you got on one sheet, there's a tremendous amount of data that can be drawn from this particular chart. Okay, now let's just have a look at a couple of bits and pieces about this chart. First of all, I'm going to deal with a couple of issues. I'm going to deal, number one, with sensible heating. The second thing I'm going to deal with is latent heating. And then I'm going to deal with adiabatic process. And remember that the word adiabatic means that there's no heat added. Or subtracted. Okay. First of all, sensible heating. Now, sensible heating speaks about one thing and one thing only. It is heat that you can sense. So in other words, if I go and stand next to a fire, my body is going to start sensing that there's heat. If I get thrown into a cold swimming pool, my body will immediately tell me that is cold. It's sensing. I can sense it. So in other words, when we talk about sensible heat, we're talking about heat that you can physically feel. So if you have a look on this scale here at the bottom, we started at a dry bulb temperature of -10 degrees, and we end at 55 degrees in terms of dry bulb temperature. Now, why dry bulb temperature? Dry bulb temperature is one of the two temperatures that we take using a sling psychrometer that is used to measure two temperatures. And the one temperature would be your dry bulb temperature. So in other words, you would have a thermometer that is just placed into the sling psychrometer and completely exposed to the air and the air elements. The next one is the wet bulb, and that is as you will remember, we were talking about it up on that line over there, the wet bulb with saturation temperature. That is another thermometer that's placed into the sling psychrometer, and that bulb of the thermometer has got a wick on it, and that little wick goes down into a source of water, and so in other words, it keeps the bulb of that particular thermometer keeps it wet all the time. Hence the name wet bulb thermometer or wet bulb temperature. So when you take this, it's called a sling psychrometer. Both of the thermometers are inside the sling, and you practically just sling it around. So there's a handle on it, and you will stand and you'll just basically revolve it around its axis, and you'll by slinging it around. And what that will do will draw air into that psychrometer, and it would then give two readings. You'd read the actual temperature, the daytime temperature of the dry bulb, and you would then read the saturation temperature of the wet bulb. Okay, now we were on sensible heating. Sensible heating, or sensible cooling for that matter of fact, takes place in a straight line. So in other words, if I have a look here and I say there's 15 degrees and there's 30 degrees, so if I move sensible heating from 15 to 30 degrees, I'm just going to be moving technically in a straight line. It could happen over here from 15 to 30 degrees. So in other words, all I've done is I've just made things a lot hotter, a lot warmer. Or alternatively, I could say, right, okay, I'm cooling from 20 degrees to 15 degrees. So all it is just a straight line. Sensible heating. If I had to say to you that I'm going to be increasing the latent heat. Now, I want you to understand that this axis over here deals with sensible. And this side over here, this axis over here, it deals with latent. Now, latent refers to the water content. So if you are told that you are increasing the moisture content, or you're increasing or decreasing the latency, it would mean that if I'm moving from 0.01 to 0.02, I am going in that direction, 0.02. So in other words, I've increased the amount of water vapor in this mix. Now we increase the amount of water vapor in the mix by adding sprays into our airflow. Alternatively, if we dehumidifying, so that is humidification. So in other words, if I'm going upwards, that'll be humidification. If I come down, for argument's sake, so let's say I come down from 0.016 to 0.01, I'm dehumidifying. And what's happened is I'm stripping water out of the air, and in that particular place, in that case where I'm going upwards, I'm adding water to the air. Then the third one that we deal with is adiabatic